This video presents a brief overview of the Leak Detection and Repair Simulator, or LDAR Sim. Over the past 10 years, there's been a remarkable amount of innovation in methane measurement technologies. These technologies are extremely diverse in their spatial and temporal scales of resolution and the types of information product that they are able to deliver. These technologies range from handheld systems, such as cameras, to continuous measurement systems, vehicles, drones, aircraft, and even satellites. While the deployment platforms differ, the sensors themselves also differ, and the analytics and work practices differ as well. So it can be extremely complex understanding what the emissions reduction potential and costs of these different technologies are. In order to better understand how these technologies might perform in terms of their emissions reductions effectiveness, their cost comparisons, and the technology performance over time and space, the Leak Detection and Repair Simulator creates a virtual world that allows comparison of different technologies, methods, and work practices. LDAR Sim is an academic project that began several years ago at the University of Calgary and has since flourished into a vibrant open source framework that has passed through peer review and has many designers and participants from industry and regulators and academics who have been involved in its creation and design and development. How does LDAR Sim work? LDAR Sim creates a virtual world of oil and gas infrastructure that is informed by emissions profiles. Every day, coins are flipped for every type of infrastructure that exists to understand whether leaks are likely to arise in the virtual world. Some days, some types of infrastructure, leaks may arise. Other days, nothing might happen. Over long periods of time, leaks do arise in various places. And over many days, many leaks are likely to arise. Because in the real world, it's unlikely that leaks will just increase indefinitely, LDAR Sim contains natural repair processes that represent operators eventually finding leaks and taking care of them, or repairs that occur accidentally through retrofits and refits and upgrades. After long periods of time, you can see that the leaks in the virtual world baseline tend to change. LDAR Sim then applies technologies, methods, or work practices in order to understand where leaks are and test whether they can be detected by different methods. Close-range methods and screening methods are the two primary ways that technologies can be deployed within the LDAR Sim virtual world. With close-range methods, agents travel around and try to determine leak by leak whether the leak is large enough and whether it can be detected by different types of technologies. You can see that agents will travel to each and every piece of equipment and survey each and every component, even if there aren't leaks present there, to determine whether there are leaks in the system. After some delay, the leaks are tagged, repaired, and removed from the system to understand overall emissions. Screening methods are different because they measure at the site level. They will survey all of the equipment at the site at the same time and make a determination over whether or not there are emissions from that site. If a screening method does find emissions at that site, it flags the site. Close-range methods then do follow-up to determine whether there are leaks that can be diagnosed and issued repair orders for. But those close-range methods won't waste time traveling to the sites that aren't flagged. You'll notice that in this process, the close-range methods are quicker, but they may miss some leaks at the sites that weren't flagged. Version 2 of LDAR Sim has now been released and has lots of improvements, including detailed user manuals, capabilities to use satellites, more advanced agent scheduling, follow-up capabilities, better weather in the virtual world, automated sensitivity analysis, improved economic functions, labor calibration, and much more. Implementation of LDAR Sim can be quite complex. Please remember that this overview video is a very simple representation of a far more complex model. You should be careful about parameterizations and understanding how everything works before you make decisions based on LDAR Sim's results. If you're ready to learn more, you can check out LDAR Sim. All the code is available for free on GitHub. We also have resources like an LDAR Sim story map and peer-reviewed publications that explain in detail how the model works. Please get in touch with us anytime if you'd like to be involved or to learn more. Thank you.